If you work in IT security, you've heard of ISO 27001. But what happens when cybersecurity shifts from servers and switches to power grids and substations? That's where ISO 27019 comes in. Power transmission and distribution systems, substations, SCADA, control rooms, these run on operational technology, or OT. Unlike IT, these systems weren't designed with security in mind. Their top priority isn't confidentiality, it's availability. If a substation goes down, entire cities lose power. That's why patching, reboots, or quick fixes that are routine in IT just don't work in PT&D. So let me give you some context about where ISO 27019 fits. Within the ISO 27000 family of standards, the ISO 27002 standard gives general security controls that apply to any IT environment. ISO 27019 was created because the energy sector needed something ISO 27001 couldn't provide. Power grids depend on control and automation systems. These have different priorities from IT. ISO 27019 focuses on those control systems, not on business IT networks or customer systems. Organizations still certify against ISO 27001. ISO 27019 just adds sector-specific guidance on how energy utilities and operators should apply security controls. The risks here aren't about data loss. They're about outages, damaged equipment, and of course, safety. And in a global security context, regulations like NIS2 and IEC 62443 push utilities to follow exactly this kind of framework. To summarize, ISO 27019 bridges the gap between traditional IT security and the operational reality of keeping electricity flowing. As I just mentioned, ISO 27019 takes the familiar framework of ISO 27001 and adapts it to the energy sector. So, what do these modifications look like? Okay, let's start with access management. It's not just about authentication. It's about making sure only authorized engineers can remotely connect to a substation, because one wrong login could trip a breaker. Monitoring. In IT, you log database queries. Here, you log every remote switching command. So, for example, if someone opens a circuit breaker, you know it was an operator or an attacker. Patch management. In IT, you can reboot a system. In PT&D, you can't just restart a control system. So ISO 27019 calls for network segmentation and intrusion detection until it's safe to start the patching. Incident handling. Clearly, you can't pull the plug on grid equipment during an attack. The standard requires containment strategies that keep electricity flowing while you respond. Of course, ISO 27019 doesn't just adapt ISO 27002, It also adds a few controls specific to energy and OT. First, it adds security requirements for industry-specific communication protocols like IEC 60870-5-104, DNP3, and of course IEC 61850. Second, it defines stricter rules for remote maintenance connections. What I mean is things like using VPNs, jump hosts, and session recording. Third, it includes guidance on securely starting up and shutting down control systems. For example, after a substation outage. And finally, it links security controls directly to business continuity and grid reliability. That's something that ISO 27002 doesn't emphasize. These additions make ISO 27019 more than just an adaptation. They make it operationally relevant for real-world grid environments. Let's make a high-level summary. In IT, if you reboot a router, users will grumble. In PT&D, if you reboot the wrong system, the lights go out for thousands of people. That's why ISO 27019 exists, to adapt tried and trusted security controls without breaking the grid. To conclude, ISO 27019 takes the familiar ISO 27001 framework and applies it to the realities of the power grid. It's the same principles of information security, just adapted for systems where reliability and operational continuity come first.